Hi guys, welcome back to the channel. My name is Jag, and in today's class we're going to continue with our Calculus 12 content. What we're going to go through today is going to be the derivative of a polynomial function. So with that, let's get started. Okay, so here we are. And so what we're going to do is some questions from the textbook here. So this is actually really important, the derivative of a polynomial function. So this is without using the first principle derivatives. All right, so I'm going to write down our first question. So it's y equals 5x to the 6 minus 4x cubed plus 6. So say this is the actual function here, okay, for a polynomial. Remember in the past video, what we did was actually use the first principle derivatives. And this time we're not going to do that. We're just going to use the shorthand method of finding the derivative. Again, when you are using this method and you're finding the derivative, make sure you put that line on top here. So this is y prime. Okay, so what you're going to do is you're going to bring down the exponent. Okay, so I'm going to put 6. Okay, like this. And you're going to multiply it by the derivative here, which is 5x to the power of 5. Okay, so you are basically just subtracting 1, okay, from the exponent here. And you can see that you'll get the same answer here, okay? So you're bringing the exponent down, subtract 1 from the exponent, so 6 minus 1 is 5. Same thing here. We're going to bring the 3 down, and it's going to be 4x to the power of 2, because we're just subtracting 1 from the exponent, okay? If you look at the 6 here, I notice there's no x, okay? So it's just going to be 0, so we don't need to write that down. And I'm just going to put an equal sign. Okay, we're going to do the 6 times 5 here. So we're left with 30x to the 5. Okay, and the second one, we're doing 3 times 4, which is 12x squared. Okay, and this is the final derivative for this question here. Everyone is good? Let's try another example. So there'll be a lot of examples, okay, where you have like the square root function happening. So let's try this one. I have f of x equals to negative 3x to the 5 plus 8 square root x minus 9.3. Okay, so I notice it doesn't really matter, okay, even if you have a decimal here. What we'll do is I'm just going to rewrite this. So 3x5 plus 8x, this is square root x, so x to the power of 1/2 minus 9.3, okay? So anytime you do have a radical, we are just going to change it back into the exponential form. So let's put f prime of x now. Okay, so now we can take the derivative. We're going to bring the 5 down, and we're left with 3x to the power of 4. So just subtracting 1 from the exponent there. And the same thing here, okay? I want to bring the 1/2 down. So let's put plus 1/2. And this is 8x, and you're doing 1/2 minus 1, which is going to be to the power of 1/2. The 9.3 is going to be equal to 0, so you can just leave it the same. Okay, and now you can just multiply these exponents out, or the coefficients. So we're doing 5 times 3, so 15x to the power of 4. This is 1/2 times 8. Okay, so plus 4x to the negative 1/2, like this. And again, don't leave these negative exponents, okay? We're just going to take it to the bottom. So 15x to the power of 4 plus 4 over square root x. Okay, so notice at the end, I am changing it back into the radical form. Okay, and you can do that as well. Okay, does anyone have questions there? Okay, so basically we're changing this. If you have a radical, change it to the exponential form. Okay, and that way you can actually use this rule very easily when you're when you're differentiating the function here. So with that, let's go to the next example. Okay, I have g of x equals, I have 2x minus 3 and then x plus 1. Okay, now I notice I can use the product rule in this case as well, but we're not going to do that. We are just going to FOIL this out and open up the brackets. Okay, so we're going to do 2x times x, so I have 2x squared. And then you have 2x times 1, so plus 2x. Then take the second term here, negative 3. You're going to times this by x and 1. So negative 3 times x, negative 3x. Negative 3 times 1 is negative 3. Okay, then we're going to put these like terms together here. So I'm left with here 2x squared, 2x minus 3x, negative 1x minus 3. Okay, I'm writing the 1x here, okay, just because we are going to differentiate it now. Okay, so I'm going to put g prime of x equals, we're bringing down the exponent 2. And for the 2x squared, you're going to do 2 minus 1. Okay, so we're just left with 2x here. If you look at the exponent on x here, the negative 1x, it's 1. So this is just going to be 1 times negative 1, which is negative 1x. Right? Negative 1x, 1 minus 1, which is 0. Okay, so for the x, it's actually gone here. Okay, so what we're actually left with is 4x minus 1. Okay, and that is the differentiated form. Okay, here we're using the difference, the constant multiple, the power, and the constant rules. All right, so with that, we're going to try just one last example. Okay, if there are no questions. So let's write it on this side right here. Okay, so this time I have h of x equals negative 8x6 plus 8x squared. And then the whole thing is divided by 4x to the power of 5. Okay, so say this is my expression. In the next video, we will be going through the quotient rule as well. So right now, we're not going to use the quotient rule. Let's just simplify this out. So I have negative 8/6 over 4x to the 5, and then plus 8x squared over 4x to the 5. Okay, so we're basically just dividing each of these terms by 4x to the power of 5, so we can just reduce it. Okay, so what we'll do here is negative 8 divided by 4, so I have negative 2. And the x is going to be 6 minus 5, so x to the power of 1. Okay, so remember, because we are dividing, okay, with our exponential rules, we're just subtracting the exponents here. If you go to the next term, we're doing 8 divided by 4, which is equal to 2. So 2. For x, you're going to do 2 minus 5, so I have x to the power of negative 3. So just like this. Okay, so we're not going to change this negative exponent, okay, because we just have to differentiate it. Then I'm going to put h prime of x equals, okay, and then we're going to do again, on top of the x is just a 1. Okay, so what you're doing here is just negative 2 times 1, so negative 2x. Okay, you're bringing this negative 3 down, so maybe you'll just make an arrow. Okay, I'm going to put plus negative 3, and this is 2x, and this is negative 3 minus 1, which is to the power of negative 4. Does everyone see that? So that is really important, especially when you're dealing with these negative exponents. So this is what we have so far. Okay, and again, we do have to just simplify this. So I'm left with negative 2x. Then you're doing negative 3 times 2 here. So this is negative 6x to the power of negative 4. Okay, just like this. And then what we want to do again, okay, is I don't want to leave the negative exponent here. So we'll just add one step. So I'm left with negative 2x minus 6 over x to the power of 4. Okay, and you're just taking this negative 4 to the bottom, and when you take it to the denominator side, okay, you notice the exponent is just going to become positive. All right, so this was basically really just a simple lesson, okay, on the derivative of a polynomial function. As you can see, it's just kind of like a power rule. You're bringing the exponent down, okay, to the front as a coefficient. And from the exponent itself, you're just going to be subtracting 1, okay? When you get really good at it, you don't really need to like show your work like this, okay? The teacher knows that you're bringing the exponent down and just multiplying it. Okay, be sure to simplify at the end. There shouldn't be any negative exponents like this. Take it to the bottom. If it is a fractional exponent, you should change it back into the radical, okay, in your final answer. Okay, so that looks good. And if there are no questions, that does bring this video to an end. Thank you so much for watching. Please make sure you do like, share, and subscribe to the channel, and I'll see everyone in the next video. Thanks, bye.